Hi everybody, it's Mrs. Dunn. Today we're talking about hypothesis testing. Specifically, we're going to be testing a claim about a proportion using the TI-84 and the one proportion z-test. Okay, so what we're going to cover in this screencast is we're going to learn and use the procedure for testing a claim made about a population proportion P. And we will be using the p-value method in our calculator, the TI-84 and the one proportion z-test to do this. Okay, what will we need to know to do this hypothesis testing? Well, we're going to need to know H null, the null hypothesis, H1, the alternative hypothesis, whether the test is left-tailed, right-tailed, or two-tailed, the p-value, and the level of significance. We'll be using our calculator to identify the p-value. All the other things we'll know from looking at the examples. Okay, so just so that you don't get confused, because we're entering another p term. So the p-value is different from small lowercase p, which is the population proportion, and p hat, which is the sample proportion. The p-value is an area. So in a left-tailed test, the p-value is the area to the left of the test statistic z. In a right-tailed test, it's the area to the right of the test statistic. And in a two-tailed test, it's going to be the area to the left and the right of plus or minus that test statistic z. There's one more phrase that I find very, very helpful when I'm asked to interpret this hypothesis test. So the phrase is, if P is high, then null must fly. And if P is low, then null must go. Memorize that and think about that every time you're forced to make that decision with your hypothesis test. So if P is high, which means if P is greater than the level of significance alpha, then you failed to reject the null hypothesis. And if P is low, which means P is less than that level of significance alpha, then you reject the null hypothesis. P is high, null must fly. Fail to reject. P is low, null must go. Reject the null hypothesis. Okay, the best way to understand this is to work through an example. So let's get started. Okay, consider this. The drug OxyContin is used to treat pain. In clinical trials, 227 subjects were treated with OxyContin and 52 of them developed nausea. Use a 0.05 significance level to test the claim that more than 20% of OxyContin users develop nausea. All right, what do we know? Remember, you want to identify the null hypothesis, the alternative hypothesis, X, N, whether the test is left-tailed, right-tailed, or two-tailed, and the level of significance. You can pause the video and see if you get these right, but I'm going to show you the answers on the next screen. So, the null hypothesis is P is equal to 0.2. And the alternative hypothesis is P is greater than 0.2, which is our original claim. Let me point that out to you in the question. It says we're testing the claim that more than 20% of OxyContin users develop nausea. P is greater than 0.2. P is greater than 20% is the claim that we are testing. So that is our alternative hypothesis. Remember, the null hypothesis is always an equal sign. So if we're testing the claim that P is greater than 0.2, then our null hypothesis has to be that P is equal to 20% or P is equal to 0.2. So in this example, we did a trial with 227 subjects. That's our N value. 52 of them developed nausea. That's our X value. To determine if the test is left-tailed, right-tailed, or two-tailed, simply look at this inequality. Which direction is the inequality pointing? It is pointing to the right. That's why this test is right-tailed. And the significance level as stated in the problem, is 0.05. Okay, so let's do this on our calculator. So to do it on our calculator, we're going to press the stat key. We're going to be conducting a test, so toggle over to test. And we're doing the one proportion z-test. So access that menu. We are testing the claim, remember, that null hypothesis is that p is equal to 0.2. So 0.2 is what we're going to put for p null. X in our example is 52. N is equal to 227. What kind of test are we doing? We're doing a right-tailed test. So we're going to pick the inequality that is pointing to the right. And then we're going to press calculate. Okay, the test statistic is 1.0951. The p-value is 0.1367. P hat is, remember, our sample proportion, 0.229, and n is the number in our sample, which was 227. So this is the p-value right here. P is equal to 0.1367. So let me show you how we're going to interpret that on the next page. So we got a p-value of 0.1367. That means the area to the right of the test statistic z is 0.1367. Remember what I said. If p is high, null must fly. If p is low, null must go. P is 0.1367. And our alpha, our level of significance, is 0.05. So the p-value is greater than alpha. So that means we have to fail to reject the null hypothesis. P is high, null must fly. Fail to reject the null hypothesis. So the conclusion is there is not enough evidence to reject the claim that more than 20% of OxyContin users develop nausea. Okay, making sense? Let's do another example. The Hawkeye electronic system is used in tennis for displaying an instant replay that shows whether a ball is inbound or out of bounds, so players can challenge calls made by referees. In a recent U.S. Open singles players made 879 challenges, and 231 of them were successful. Use a 0.01 significance level to test the claim that fewer than 1/3 of the challenges are successful. All right, identify what we know. Pause the video and see if you can identify all these values. So remember, the null hypothesis is always equal, so P is equal to 1/3. And H1, the alternative hypothesis, is P is less than 1/3. We're testing the claim that fewer than 1/3 of the challenges are successful. So P is less than 1/3 is our original claim. In this example, X is equal to 231, N is equal to 879. This test is a left-tailed test. The inequality is pointing to the left, and the significance level is 0.01. Once again, how we do that on our calculator, we'll press the stat key, tests, one proportion z-test, and here we have 1/3. So I'll type in 1/3. That's going to change it to a decimal. In our example, X is 231, N is 879, and we're conducting a left-tailed test. And I'll have the calculator calculate that. Okay, so the p-value is this 4.58 e to the -6. Remember that e to the -6 means times 10 to the -6. So basically, you're moving this decimal point 6 places to the left. So essentially, that p-value is 0. So the p-value is 0, and 0 is less than 0.01. Therefore, remember, when p is low, null must go, we are going to reject the null hypothesis. The conclusion: there is enough evidence to support the claim that less than 1/3 of all challenges are successful. Okay, that's all you got. That's all we have. Good luck.